So what we want to do here is we want to write an equation for the graph provided. And we have roots at 0 and 2. X equals 0 means we're going to have a root at x by itself, or you can say it's x minus 0. That's another way. I'll even write it up here. X minus 0 is one way of writing that, but the other one is at a positive 2, so we say x minus 2. And so either one of these two are viable ways of doing it, but we got to pay attention to the fact that this goes through slowly, or we call it goes through the squiggle. Okay, that means that location is a third root, a triple root. So we want to raise that to the third power. Okay, and we can do the same thing up here. In addition to that, both of these arrows are going down, and whether this one doesn't matter as much, but the fact that it's going down to the right means that there is a negative out in front of there. Okay, and as we look at that, then we also want to pay attention to what is the interval where the graph is positive. Okay, so we're identifying at 0 and 2. There's open circles above because it's not positive when it's on the x-axis. It's actually equal to 0, but it's only above between those two, so we connect the dots and we're in business. We're good to go. You look over here to the next one, and we'll do the same thing. We'll do a couple of them. 3 roots. We have 1, 2, 3, x plus 3. We have, well, this is an x minus 2. And here I've kind of left myself with a 0. You can plop that guy right out there in front, or again, you can call it an x minus 0 out in front if you want to. It's going up to the right, which means it's a positive out in front. There's no double roots or triple roots, so we're done there. That's about that. And onward to the fourth one. I'll give you, let you work on this one. There's 3 roots, 1, 2, 3. There's one at x equals, or x minus 0. There's one at, looks like 1, x minus 1. And then there's one at 2, x minus 2. Each of them are bouncing, so each of them have a squared. And because it's going up and to the right, we can say that it's positive, so nothing out in front necessary. Oops. I forgot back here. We're going to go back to negative 3. We're going to go to 0. We're going to go to 2. And those locations where it's above, it's only above here between these two. So we're going to say open circle connect. We're going to say open circle and directional that way. It's only above as you go to the right of 2. And so that's why we're kind of identifying that. Over here, it's an interesting thing that's happening here. We have 3 roots at 0, 1, and 2. We have open circles aplenty, and you'll notice it's never below. It's always above, so it's going to be forever that away, forever this away, and also in between. You don't want to fill in the dots because it's not a positive. It's not above the x-axis until you get off of the x-axis.